All right. So at these slides, introduction to object-oriented programming, OOP, in Python, and I wanted to review overview over OOP concepts and detailed explanation for each concept. I wanted to go over class and object and inheritance and polymorphism and encapsulation abstraction, and some examples. Add some in the review. What is object-oriented programming? Well, it's these to have the code as objects. These will make it easier to use and easier to manipulate the data, and it gives us benefits like we can make them modular and a lot easier to use, and we can maintain them easier and more scalable, and it saves us from rewriting the code a lot and with classes and objects. I'll show you through examples. It's very beneficial in not we don't have to rewrite the code over and over again. We can just write a class and make objects that updates the data saved within the class. And there's another benefit. Keep going. Introduction to classes. I have an example here. A class is a blueprint for creating objects. Yeah, classes lets us. Here's a class dog, and make it bigger. The dog, and we made a species canine. So, we initialize the name and the age. So this is initially a part here to use them, and then here a class for bark. So return. It'll say the name, and then what it does says wolf. So the species canine, and then name. These are attributes right here. That's why we need to initialize them so the class can identify them and we can now use them. And then method is the bark here. Self to connect it to the rest of the class. And it says wolf. So when we use this, in the next slide we'll be using it. We can use method and update the name or age. So here, understanding the object. An object is an instance of class created with specific values. So we give it a specific value, buddy, and we have a way of okay, this is the object, my dog, and we call on dog, that's from here, the class. We're calling the class buddy. We give it the string for the name, and the 4 is the age, the integer value. And now we can print it. Print my dog dot bark. We can this already updated that class attributes, but this is the method, so it'll display whatever information. It'll do whatever bark is doing in the method, which was return f print. It's gonna print this out. Name, so only call name, and then says wolf. So my dog says wolf will be the output of that. Inheritance classes. I'll make this bigger. Definition. This is for inheritance. Inheritance allows a class child to inherit properties and methods from another class parent. So the we make another class, and this will be a child class, and we put it here. Class cat animal. We're calling on this class, and then we can now update whatever this animal class is doing. So this one is just having a name, initialize name, and then speak self. Name makes a sound. So whatever name we give this makes a sound. Now we can update that class with this child class. Cat. It has a method speak self. This name says meow. So we can, if this has a name, then it'll pop up here. But we can. So the benefit of this is reuse this code here. We didn't need to initialize the name. We didn't have to do it for this, for the child class. And so that saved us time. But we can manipulate the name here so we can have more objects. And we can display new information here. Polymorphism definition. Polymorphism enables methods to differentiate behaviors in different instances, even if they share the same name. So even though they have the same name, they will act differently. This is good for clarity and more clean code. If everything has a different, we don't have to rewrite stuff. We can source it to the parent class easily, like here animal to the dog class. So this this is a method outside, so it's not a class. I mean a child class. This is just calling on animal. Speak self. This is a method in the class, and then it says wolf again, and then this will animal sound. This has its own print animal speak right here, and animal will call onto this, and we're calling on this function here. And this is where this polymorphism acts, because now we have objects: cat, Luna. So we're calling on this function. This is connected to the previous one. So we're calling on that one, and we're updating the name to Luna. So this has a name. So here it says meow. So Luna, and then we make another one, dog. This one is the parent. No. Yeah, we're making as if there was another one. These are connected. These are snippets of the code. Dog is called, and it's given Rex as a name. And so when we call animal sound cat, Luna says meow. That will be the output. Luna, new name, says meow. And then the dog class here says wolf. So this class. So you see that here it's given this. We're using it here, and we're taking the function from here, the method from here. Even though they're named differently, dog, animal sound, we still can take the function from here through polymorphism. Yes. Abstraction is useful because we don't need to know everything that's working on in the Python script or everything in our function. Like if we were to use insert or math methods, we don't need to understand every little thing about what methods we call on, or those call functions, like from math, forgetting the library, but when we call the math library, we don't have to know what cosine or sine or whatever function we're using. We don't need to know every detail, but we know what it does, and that where abstraction helps us. Or we don't need to know everything, but it still can help us in whatever example or whatever problem we're solving. Here's an example. This one, import ABC. We don't need to know what ABC is doing, but it's helping us like finding the area, finding perimeter, the width and height. With the height, we like it. It makes it more clear and takes away all the complexity from it, and it simplifies the code for us. Here's some practical applications of OOP. Game development. Python can also be used. I know C# is the most common practice, but the OOP can is more the object-oriented programming part of it, the aspect when they make objects for game characters like sprites, which are the game characters you see on the screen. They're separate from the background, and those are separate objects, and those can be used with their own logic, and that simplifies everything to be more understandable for programmers and game developers. So it won't be all in one script, and they don't have to be working all scrambled and not clear. Web development frameworks. I've developed some web applications before, and it's much easier, more clear to make objects that do specific tasks instead of everything being connected together. Like buttons and menus and separately. GUI applications. GUI applications you can separate. When like making an application and you're making buttons or certain logic that saves data, like a budget app. I've been working on a budget app for another class, and the data you can update the numbers within the class, and you won't let the user be able to update that information without accessing it through methods you've written before through other child classes. That was a project we worked on, and so that is a great benefit to through OOP fundamentals. Discussion points: how OOP helps designing complex systems. I covered that. Reusability and modular benefits. I wanted to review over what we talked about more clearly. Yeah, summarizing it. Yeah, I wanted to summarize these concepts I covered, and see if you can see it. Yes. Okay. Yes. What it is? We can turn these. It's more. You could program without OOP, but this makes it easier, more clear, and much more modular, and saves you so much rewriting of code. And it's actually safer because you can cut out access from users from certain objects in the class, so it's much more manageable. Here, is a class overview. Okay, it's about the same, but uh, describing a class like a blueprint or template. Uh, yeah, it's more of the basic framework of what the class will be, how the program's gonna work, and its objects, methods. The structure is the attributes being made here, and since attribute unique to each dog. Yeah, you see species canine, class attribute shared by all instances here. And it's constructor method to initialize each object. So here is they're being initialized, unique to each dog. So dog class, name age, and bark says wolf. Behavior methods. This is the method. This is its behavior, what it's gonna do. The object's instances will have. So yeah, this is just description. Moving on to object. A object in the instance. When you create an object, you're making an individual item based on the blueprint provided by the class. So on the blueprint, which was made by the class, we can make an object now. My dog buddy. We gave the string and the integer like before, but we can make another neighbor dog using the same class. Max, we have Max now, and we gave him like 5 years. He's 5 years old. Each object holds its own data and can call methods. So we can print them now. We can print the object with the method from the class before. And buddy says wolf. And then neighbor dog has a different object of with different data. So Max says wolf. So that's why that's useful. We save so much. That's much more clear code and very easy to understand. Inheritance. Let's one class called a child or subclass take on properties and behaviors, attributes, and methods or another class called an object or superclass. So parent class, this is the parent class animal and class inheriting from animal. This is the class, and this we initialize the attribute, and this is a method. Self makes sound. Child class inheriting from animal. Self says meow. This is the child class, and using classes. So we're almost done here. So what we have left, yeah, we're gonna go through it. So we make these objects, generic animal generic, we're using the classes. So we called on animal, and we made the object here. And kitty, cat, whiskers, we gave it the string whiskers. That's the name now. And then print generic speak. The method make sound. So generic make sound. Timer went off. And kitty speak. So whiskers says meow from this object here. Or not this object. This child class has this method. So polymorphism, let's go through this quickly. Many forms, it allows objects in different classes to be treated as objects of a superclass. And same method can behave differently on different classes. Okay. Oh my goodness. Hold up real quick. So example in Python. Okay, animal, cat, and dog classes exist. So we made these classes and speak self. Here's the method. Here's the regardless of animal or cat. So here is this method here. Using polymorphism, cat Luna, we update the name. So whenever we say we call on them, we give these objects, Kitty and Rover, which have these strings, give them the names. So this, so we called on this one, this, it's not a class, it's a function, but this is calling on the class, and polymorphism is allowing us to say Luna, use this method, and this will say Luna says meow, Rex says wolf. It's very beneficial because we didn't have to rewrite a lot of things, and we can just make objects whenever we want, changing the names. So that's very useful. Encapsulation involves wrapping the data attributes and the code methods that work on the data in single unit a class, and restricting access to some objects components. Okay, this makes it very secure rather than C++ and C, because those aren't very secure and are very vulnerable, like fundamentally. So that's why Python and other object oriented programming based code will now be more used now, because they're a lot safer. Like my example earlier, the bank account example, here is the class made, and self balance, we initialize balance. Here's a method. We had a project like this doing exactly this, and this is a good example. So here's the methods that the user can access, and when they contact it, but we're just using like a terminal we're just writing this in the terminal, just in the bank account. So we give it we start out with 1,000, and we can deposit 500. Print current balance, account get balance, output current balance, and then count, we get balance, we get balance. So we call on this instead of this. If they have access to the original and make whatever, this is just to check on the balance. This is not the actual balance. So they would not be able to access the balance itself. So the current balance, because after we added 500, it's 1,500. The encapsulation is like having a lockbox class where you can only modify or retrieve contents data by using the proper keys methods. This protects the data from being changed in unexpected ways and keeps the internal workings hidden from the outside. So yes, it keeps the important data safe, but also able to be manipulated the way the program is intended, not in unintended ways. Abstraction means hiding complex reality while exposing only necessary parts. It allows you to work with ideas or objects at a high level without needing to understand all the details. Import ABC. This is just the same function, but yeah, we're able to use it without needing to. We can use this objects without having to understand them. Like we write a program, but we call on rectangle, we give it 5, 10 width and height, and we can print the area of the rectangle. So area can work, and we didn't need to understand this part. Width times height, we just knew it worked to give area, and perimeter, which is Abstractions let you focus on the object, does instead of how it does it. For example, when you use a smartphone, only interact with simple icons and buttons that don't need to know about the underlying electronic circuits or software code. So that's about it. Yeah, OOP is very useful in writing programs. It makes it much easier to use and program and solve problems.